Let's deal with the tutorial on the volume of a cone. You want to find the volume, the amount of space occupied by that three-dimensional shape. How do you find the volume? Now we are going to recall from the tutorial we did on the volume of a cylinder. If we take a cylinder of equal diameter of a cone and of the same height, then it means that the volume of the cube can fit into that of the cylinder 3 different times. Let's make a sketch of that. So if we take this as a cylinder, and if this is the cylinder that has the same diameter of a cone, meaning a cone is fit into this. If the same diameter, you see that the cone is fitting at the base, which is the circular part of the cylinder directly. If you check carefully, we can see from here that the base here is forming a cone, right? This is one cone. If you check also well, this area is also going to form another cone. Then finally, this place will also be a cone. If well drawn, you'll be seeing 3 different cones that is being fit into this cylinder. As long as they have the same diameter, they will be able to fit into these 3 times. So per the diagram, we know a cone is of this, whereby from here to here give us the radius. The distance which is perpendicular to the radius form a right angle. So this is the slant height, this is the height, and this is the radius. From the previous lesson, we've learned how to find the radius when the height and the slant height is given, how to find the slant height when the height itself and that of the radius is given, and also the angle from them. We can be able to find all of them. But here we are concerned about the volume that it can occupy, or that will be occupied by a material. So since we already know that the volume of a cylinder is equals to the base area, that is the cross-sectional area. If we cut this line into 2, what you will see will be the same as the base. And the cross-section is what? A circle. So pi r squared is the area of the base times the height, how long the cylinder is. And that gives us the volume, pi r squared h. Now we are saying that the cone is fit into these 3 times. If you pour in water into the cone and you transfer into this cylinder, which has the same diameter and height as the cylinder, it's going to be 3 times. Therefore, a cone volume, or let's just say volume of a cone, is going to be 1 out of 3 pi r squared h. That is, if you divide the volume of a cylinder into 3, you'll be able to find the volume of that of the cone. So this is one way by which we derive the formula that is used in finding the volume of a cone. Now, if we consider a cone as a pyramid, we know to find the volume of a pyramid, if you are finding the volume of a pyramid, we know it is equals to the 1/3 times the base area. So you're going to have 1/3 times the base area times the height. Any pyramid you pick, you want to find the volume, we are going to have 1/3 of the base area times the height. So what is the base of a cone? The base of a cone is a circular. So this is called a circular pyramid. If you want to define it in terms of pyramid, it will be circular, because all pyramids derive their name from the base. So a circular pyramid, so the circle is having the area as pi r squared. So 1/3 the base area times the height will give us the same formula if we don't want to base it on the cylinder. So we can also say that the volume of cone will be equals to 1/3 times the base area, which is pi r square, times the height. So basically, the volume of a cone is derived by this. So let's see, for example, so if we are asked to find the volume of a cone of radius 6 centimeter and of height 14 centimeter. So this is just going to be, per recall, the volume will be 1/3 times the base area, which is pi r square, times the height. So per substitution, you'll be having 1/3 times 22/7. What will be the radius? In the question is 6 times 6 as in c squared from here, then times 14. 6 is centimeter, centimeter, centimeter. So centimeter cube will be the final dimension unit. So 3 will go here, 2. 7 will go here, 2. 2 times 2, 4. 4 times 6, 24. So 22 times 24. And when we multiply that, we have 8, 2, that will be 4, 4. So we have 8, 2, 5. So 528 centimeter cube. So all that we are trying to develop is the volume of a cone. How we can be able to find the volume of a cone based on the formula derivation. I believe in the next section, we are going to find how we can find the volume of a cone that is derived from the sector of a circle. Don't miss that episode. Come back and let's learn together. Bye-bye.